Soap is a salt of a fatty acid. When fats react with a base, a soap is formed through a process called saponification. In saponification, the fats are first hydrolyzed into free fatty acids, which then combine with the alkali to form a crude soap.
Three main ingredients. Yeah. You need an oil. Mm-hmm. I use coconut oil. You need a water or liquid, some sort of liquid. Mm-hmm. Is add my lye into my liquid, and you never do it the other way around because it'll make some sort of explosion. It'll bubble up or something like that, and it's not something you would want. So you always add the lye to the liquid, always. And so that's it. It changed colors a little bit. It's not as a pukey color. It's more of a tan color from like the oatmeal. And it smells pretty good. So there you go. Homemade soap. Okay, so we're going to try the soap and make sure it cleans. So I'm going to show the difference between soap and trying to clean with water. So this is oil. Olive oil I put on my hands. So now we're going to use just water. We're going to try to get it off with just water. My hands still feel oily. I just feel like my skin is coated. Okay, I still feel that. So let's use the soap. And it's just soap I just pulled from the blender and made a block. And it's ready to use. It's very hard, ready to use. So let's wash our hands with this. Nice lather. Oops. Okay, so that's nice and clean and soft. They just feel moisturized. I don't feel as slick as they did when I had the olive oil on there, trying to wash that off.
To help save wildlife affected by oil spills, rescue workers have opened up a lot of Dawn. They rely on it because it's tough on grease, yet gentle. But even they'll tell you, Dawn helps open something even bigger. Go to facebook.com, Dawn Saves Wildlife. Find out how the little things you do can make a big difference.
Oil and water just don't mix. You can see so for yourself. If you pour some water in a glass and add a bit of cooking oil, you'll see that they form two completely different layers. Water particles are small and stick together very tightly, but oil particles are bigger and don't stick together as well. So if water can't mix with oil to wash it away, then how can you get that oil off your skin? That's where soap comes to the rescue. Soap can't dissolve oil, but it can stick to it really well and help wash it away. If you could look at the particles that make up soap, you could see that they each have two different ends, and each end is attracted to or pulled toward different kinds of things. One end of the soap particle is pulled towards water, and the other is pulled toward oil. So when you mix soap with oil and water, one side of each little soap particle sticks to the oil, while the other side sticks to the water. And then when you rinse off, the soap, oil, and water all go right down the drain.
Let's line up a bunch of greasy dishes, then use these dipsticks to find out. Whoa, grease is getting its hiney kicked. Uh-oh, looks like one side lost its mojo, while the other is still going strong. That's Dawn Ultra, with 2 times more
Really,
everyday
the food
grease
coloring
cleaning power.
doesn't have anything to do with this experiment. The only reason we're putting food coloring in is so we can see what happens. Because milk is white, and so what's going to happen in a minute, the milk's going to start moving, we want to be able to see it. The next thing you want to do is take your Dawn dish soap, or whatever dish soap you have, in a cotton swab, and you want to dip it in there. You don't want a thick glob like that. You want to kind of work it off on the side until you have a good bit of soap there, but it's not dripping off. Okay, just like this. And then I want you to watch carefully as we actually place that inside of the milk. Watch carefully what happens at the moment we push it in. Here we go. 3, 2, 1, go. Look at that. The milk just kind of goes nuts. It completely spreads out. The green kind of completely intersected everything else, and it goes out. Let's go over here to the orange and touch the orange and see what happens. The orange flies everywhere. Okay? We'll go over here to the blue. The blue goes everywhere. So notice that as we're holding it here, the milk continues to move. You see, it's continuing to move out from the point. We're not really moving the Q-tip. The Q-tip is staying motionless, but the milk is going. Now we can use the other side of the Q-tip to kind of get it fresh, see if we can get it going even better. Let's see what happens. We'll try this side over here, and that starts to move. Basically, wherever you touch this Q-tip, the milk food coloring solution is going to tend to move out away from it. Now notice what's happening now. As I do it more and more, the effect is not as strong. See, when I first put that very first dot in there, things moved really, really rapidly, and now I can just grab a whole bunch of soap and just drop it in there, and not that much is happening. You can see it's not really doing the same thing. So you have to ask yourself as a scientist, how is this possible? How is this working? Soap in there, it started radiating and going away from the point that we put the soap in there. We didn't have to move the soap around. We just stuck it in there, and the milk just continually kind of shoots away from the point that we put it in there. And also, as we do it more and more and more and more and more, basically the experiment stops working. So that's kind of going to factor into what's going on here. What's happening is, this is an example of how soap really works. Notice, what do we use soap for? We use it when we have our hands that are greasy, maybe we've got some fat or something on our hands or some oil, and we want to get rid of it, right? So if you put that under water and you try to wash your hands without any soap, and you have really oily hands or fat hands or something on your hands that's really fattening, it's going to be difficult to get off. But you put a good quality dish soap on your hands, you rub them around really good, you put them under the sink, and you can actually start to feel your hands getting clean. What's happening there is this soap is not just a blue formula in the bottle, it's specially made to basically bond to those fat molecules and to those proteins that are in things like bacon grease and things that are in like oil and such like that. In this case, there's also fat inside the milk, and there's also proteins inside of the milk. That's one of the reasons why milk is so good for you, right? So what's happening whenever you wash your hands is that soap is bonding. It's actually connecting to the fat molecules, to the proteins. It's actually bonding to those molecules, and then the water is able to wash it away. So it kind of goes out there and it latches on to those molecules of the fats, and then the water actually is able to wash it away. In this case, we have a nice surface of milk, right, which has fats and proteins baked into the milk. That's just part of the milk. We put the food coloring there just so we can see what happens. And at the moment that we put the Q-tip into the solution, what happens is the soap starts bonding with those proteins, and it causes the milk to start to move, because what happens is those proteins and those fats, they you can sort of think of them as being agitated. They're bonding to that soap, they're moving away from the soap, and they start to swirl because of the chemical reaction with the soap, the same way that we're able to wash our hands clean. That's part of what's happening. The other part is that the soap actually breaks down the surface tension of the milk. So if you look carefully at a glass of water or at a glass of milk, you can kind of see that skin that's right on top. You can kind of dip your finger into the very top of a cup of milk or a glass of water, and you'll see the skin there on top. We call it the surface tension. That's just because of the water that's inside of the milk and the way that it bonds, right? And it creates that kind of skin. Soap immediately destroys that skin. that surface tension, and that's just because of the reaction that's going on as well there, the bonding that's going on. So there's two things. The surface tension is disrupted, and also the fats and the proteins start bonding with the soap. Those two things together cause the milk to physically start to move because of all the agitation going on.
Oil and water kind of repel each other, how for whatever reason they won't mix together. And you could have the students brainstorm reasons why they think that might be. And then we'd have them screw the lid on tight and try to mix it. See if they can mix it. Shake it as hard as they can. Alright. Now, it looks like at first that it's mixing together, but then after a while, they'll notice that no matter how hard, how long they shake it, eventually the oil and the water are going to separate, okay? The oil got a little bit of red in it from the food coloring, but other than that, you can clearly tell that there are separate layers. The oil being on top and the water being on the bottom. Soap, dish soap, is just, regular dish soap. Just put a few drops in there. That's all it takes. I'm going to shake this over the sink this time. And then if you look at this, it's the oil and the water have clearly mixed together. It's all one uniform substance. So, the students should notice that they mix together. And this is where you would talk about the process of emulsification. That's what's happened here. Emulsification has occurred.
Does your carpet ever feel rough and dirty? Don't avoid it. Resolve it. Our new formula with a special conditioning ingredient softens your carpet with every use. Because it's Resolve, you know it cleans and freshens, but now it also softens. So your carpet is always inviting. Resolve, a carpet that welcomes you.
Oh, I wish I was a little boy.